Hello again. Here is a wonderful problem bringing a lot of concepts together. So let's read along and see what we can do. 7.20. Triangle ABC has side lengths of 9, 12, and 15. Find the length of the median from B to the midpoint AC. Well, when I did the lesson yesterday, I said whenever it just gives you the side lengths of triangles, you should probably check if there's anything special about them or if they're a right triangle. You can use Pythagorean theorem to tell. Now you could do 9 squared plus 12 squared. Let's just do that. 9 squared plus 12 squared equals 15 squared, which gets you 81 plus 144 equals 225, and that ends up being absolutely true. But if you were a little, I don't know, I wouldn't say clever, but if you're paying attention to one day I went over this, you could also realize that 9 is 3 times 3, and 12 is 4 times 3, and 15 is 5 times 3. And you could have realized it's the same thing as a 3, 4, 5 triangle, so it has to be a right triangle. Anyway, so now we know it's a right triangle because either you identified that it's a 3, 4, 5 triangle, or used Pythagorean theorem and found that since it worked and it only works for right triangles, then you have to have a right triangle, basically. So let's make a right triangle with 90 degrees and whoops. Let's get rid of not all that. Alright, so let's get rid of that label. We don't even need to know that's 90. Let's draw our triangle. Here we go. So we got a nice triangle just like that. And is there a way to... Can I? Nah, not right now. I can't. Alright, whatever. So, we have our triangle. I'm going to say that... Alright, this looks a little smaller, so I'm going to say that this is the side of 9, 12, and 15. Now, find the length of the median B to AC. Alright, so I should probably change these points. So this one should be B. Wait, shouldn't? Yeah, because CA is the hypotenuse. Yep. So B, AB is 9, so this one has to be A. And this one, therefore, is C. Okay. So, we want to find the length of the median from B to the midpoint of AC. Okay? So, let's draw that median out using our midpoint tool. You got that midpoint of P, draw the median like that. Okay, now this kind of I mean, we could use some, I don't know, maybe some Pythagorean theorem trickery or something, but this kind of looks similar to something we've done before. Well, How about if anyone remembers when we did what was called the circumcircle? How do we draw that? Well, we have to do all the perpendicular lines. Well, whoa. Yeah, perpendicular bisectors, sorry. So, we want to draw perpendicular bisectors through those points. Whoa. When we actually draw that perpendicular bisector, it ends up going through B. So, B is the perpendicular bisector of P. And, in fact, if we draw the circumcircle, center at P, where it crosses each of the 3 points, well, what do you know? It ends up being that BP is the circumradius of the circle. So, B ends up being the circumradius. Well, that's pretty interesting. So, this distance is the same as, well, this distance is the same as this distance. Any of those radii must be the same. But we also discovered that in a right triangle, the circumradius is half of the hypotenuse. Which means since BP is equal to, we always called the circumradius capital R, and that's half the hypotenuse being 15, so it has to be 15 divided by 2. It ends up being a fairly simple problem that we can figure out with some old knowledge that we learned about, specifically the circumcircle.